Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on module 2, that is projection of solids. Now we will work on pentagonal prism and hexagonal prism. In this session I have taken corner condition for the pentagonal prism. Now let me take a problem and work out. A pentagonal prism of 30 mm base edges and sides and axis 60 mm long has a base corner on HP such that the axis is inclined at 45 degree to HP and 30 degree to VP. Draw its projections. Let me demonstrate the same with a simple model. Here I have the pentagon with certain height and size of base. In this problem, it is given 30 mm base edges and height 65 mm. 60 mm. Now, let me take this way. Keep the solid perpendicular to HP first. Axis perpendicular to HP. Or if I say axis solid perpendicular to HP means its axis perpendicular to HP. In total, it is refers to axis only. Now, since it says the corner on HP, normally we had 2 or 3 problems earlier worked out, edge on HP. Now it is corner on HP. First position, second position. The corner is on HP and the axis inclined at 45 degree to HP. If I say the longer edge containing the corner HP is inclined at 45 degree to HP, it assumes same inclination as axis. So instead of axis, I can give the longer edge containing the corner HP is inclined at 45 degree to HP. So first position, second position. Then what must be the specific requirement for this? Now you just observe for odd number of sides, triangle, pentagon, etc. The opposite side for the corner to be placed on HP is always perpendicular to VP. It is similar to the laminae problem. Or the perpendicular bisector of the corner, the perpendicular bisector of a particular side passing through the corner to be placed on HP is always parallel to VP. In case of even number of sides, diagonal passing through the corner to be placed on HP is always parallel to VP. I will explain that with the simple diagrams and then take up the actual question. Now let me take up this. Initial condition should be this. In laminae we used to take to the left, now I take to the right so that I can move forward. Here the side opposite to the corner to be placed on HP is perpendicular to VP. Okay, VP HP. Or the perpendicular bisector passing through the corner to be placed on HP is parallel to VP. So this is how we can start working. And initial position is, since the solid is inclined to HP by some angle, the axis must be perpendicular to what? HP. First position, second position. This is the normalized position, the axis inclination. Now I will make it parallel, perpendicular, so that I get the true shape on HP. So start from top view. Okay. So first position, second position. Then we can think of inclination to VP with respect to the axis, whatever the data given. Now let me take up how to draw pentagon. So again I will explain here how to draw pentagon manually. Very easy job. Draw the side first to the left because we cannot start from the corner. Easy job is to have the side. Then take 108 degrees, 108 degrees. Check twice. Normally we take 112 instead of 108. Better check twice. Then take same distance, draw 2 arcs. You not measure these two. Simply draw 2 lines to a certain length, and with these two as centers, the same radius, draw 2 arcs. Again, with these two as centers, draw 2 arcs. That's all. And check for the correctness. You just draw a line that must be parallel. At the same time, as usual, you have taken that as perpendicular. So this is how you draw the pentagon. So this is 108 degrees interior angle, 108 degrees. then you will not match. In computer, the polygon by number of sides center is there, then you know how to do it. We have done that job in laminate. Now let me start working for this. Assume that the same procedure I have followed and take this simple model and then keep it. Okay. Now draw top view with the given side value as pentagon, edge to be to the left side, so that the requirement is corner on ground, corner to the right. So even you can take like this. Just I will tell you, as I worked for the previous problems, I can take this way, but this is unusual. Better you take corner to the right side and then incline. Now I can project these points. Before that, let me name A, B, C, E. Always left extreme nearest corner. Select. Next, project these points. See that for all pentagon, B and D must coincide in this situation. Okay, B and D, because this is parallel, definitely B and D must be on a single vertical projector. Okay, now project this. Similar to triangle, odd number of sides, the axis biased towards the side here. Okay, you never get axis along BD, take care. Now this is 60, twice of this one base side, so I can take this approximate value. Okay. Now axis, how to find the axis? Identify the axis by drawing two perpendicular bisectors, any two. Preference should be given to the horizontal one because we use that in future. O in bracket O1. Next, project the same towards the front view and name all these points. This is A dash, B dash, C dash. See, this is how it becomes easier for you in sequence. I can say nearest visible points first, then D dash, then D dash. Keep in order. Now identify the base edges and corresponding corners. B1 dash, E1 dash. Normally we never write A1, B1, C1, D1 in bracket. Understood. Now dark all the lines which are required. In computer you prefer 0.5. In manual also you can start working with the dark line only if you have got confirmation. Height and all will be fixed, and then dimension this properly. So this is 30 as per the given data, is 60. So this is how you can work for the first figure, top view and front view. I will repeat. The initial position should be this way. The opposite side for the corner to be placed on HP is always perpendicular to VP, or the perpendicular bisector passing through the corner to be placed on HP is always parallel. That is what these two are important. If you follow anyone, that works out. Now we have to rotate this. See, this is the axis. For that he has given 45 degree to HP. It is one and the same as I given information. This particular side length, this length is representing the longer edge. This is the longer edge passing through the corner on HP. Okay, that is CC1. CC1 is the longer edge. Instead of axis, you can give the data like the axis is inclined at 45 degree to HP, or the longer edge passing through the corner HP is inclined at 45 degree to HP. Not the same. Next, redraw it. How to redraw? You know, C1 must be little away from that. Take 1.5 times or little more than this distance and then redraw it. See, this is very simple geometry. Here you have this point and then you have to do this. Okay. So, what exactly I do is I take this projection okay, and then draw 45-degree line first. That is the very important thing. Draw 45-degree line through this. Like this you draw. Okay. So the distance you have, set the distance and mark. Okay. Then draw two perpendiculars. Manual information I am giving. Compute it's easy. Move and rotate. Here you have to take this. Now I am taking these distances. With compass you take one by one and do it. So the people commit mistake by taking the distance from this side. First they mark base and then start taking from this. It becomes ulta. Take carefully. I have taken distances from C. Okay, say this distance. Let me repeat. CB1 this. Okay. Yes, I have taken proper. If you do ulta, marking this base first and then do ulta, then it becomes wrong answer. Same thing, you mark here, the same compass, the radius, take this and draw this. And also one more important information is, say I have purposefully done this job. I have taken this edge, fine. Instead of taking a axis, I have taken edge. So it must be edge. This is axis. This happens many times. But in computer it never happens because you are moving and rotating. That's all. Now, name this and dark the same points. This is A1 dash, A dash, E1 dash, E dash, B1 dash, B1 dash, B dash, D dash, C dash. Same thing I repeated. I redraw this figure such that this axis is inclined at 45 degree to HP. Okay. Now, after you confirm that this is the position, you can dark manually drawing. Computer already you have taken everything 0.5, it will come as such, no change. See that it should be rotated on par with the requirement. That's all. So this is the second figure, top view, when it is inclined at some degree to HP. Corner is on the ground. Still the axis of the solid is parallel to VP. Okay. First position, second position. Okay. The top view of this particular solid will change now. You get two laminate eye and the lateral surface, everything. But here you can see only the top face. Now, then draw two extreme lines, lowermost and then rightmost, so that you need not have to project unnecessarily. Using this alignment indicator, you can do better in case of this. Now, draw this. Get the top view of the solid in the second position. So, I can always use the logic of having this pattern, pentagonal pattern, and I always stress you please avoid this axis reference. If you take axis reference, what happens I will tell you. You avoid this first. Suppose if you don't avoid, what will be the problem? Now this is the side A, this one is B, A1, B1, this is C1, this is D1. This is A, this is B, C, D. Now I have assumed that I have not taken the projection of axis. Absolutely avoid. Why? I will tell you. Suppose that you draw the axis projection also. In hurry, what we do is, instead of naming this point as D, we name this point as D. This is most dangerous. Okay. See, it happened many times. I've seen people. Okay, and one here, then one more here. Instead of that, you will get some random figure. Don't do that. Always you prefer to have only the corner projections first, and then finally you try to include the projection of axis and then name it. Otherwise, don't project the axis. So this is very important information. Now draw thin lines first. Join all these base corners and top face corners. Join them in order. A1, BB1, CC1, DD1. And now I will tell you the boundary of the figure is this. Starting from A1, B1, B, C, D, D1, E1. This is the boundary of the figure. And top face is this. And projection of base is this. Now I can select any one of the method. Best method is, simple method is, the farthest item from you here is this. Let me take this. Farthest item is C1. Base corner C1. Base corner C1 is not visible. Okay. Now, how to finish? You can quickly finish this job. The farthest item from you is C1. C1 is not visible. Any number of lines connecting to that are not visible. What are the lines connecting that? B1, C1, D1, C1 and CC1 are not visible. That's all. See, draw hidden lines. Yes, that's all. All remaining lines are visible. Okay. Now start from A to B. Boundary, you fix boundary first. Or anything. Better you fix boundary. Then fix any other line. No question of thinking twice. It's simply regular procedure. The farthest point from you is not visible. Any number of lines connecting to that are not visible. All other lines are visible. That's all. Very simple way of working. Now, but you must identify the farthest item from you carefully. Okay. Now, what about the axis? Axis is most dangerous initially. Now it must be identified, projected properly and identify. This is O1 and this is O. Initially, if you do it, chances of getting mistake is there. Now that's all. This is completed. Top view, second figure, top view. Now, what about third figure? Top view. How to draw top view? That all depends on the given information. See, information is this. The axis again inclined at 30 degree 2 VP. I have two cases again directly 30 degree 2 VP and appears to be, that we will discuss later. In this case, it is 30 degree 2 VP. What you do? Axis, there is little scope for axis mentioning here, identifying, presenting that. Okay. But O1 to O is already covered by the hidden line. Visible line, hidden line, axis, then construction line. Now, I have to keep this O1 on 30 degree line. Is it possible? No. I cannot give apparent length on true inclination. No. True length is always associated with true inclination. Apparent length must be placed on apparent inclination. So, find beta because this is apparent length. So, this is apparent length. 60 has become some distance here. In computer, you will get clear idea. Even manually, if you do it properly, you will get approximate idea. So, O1 is apparent length. So, I can say apparent length on, apparent length on apparent inclination. So, you know very well how to find apparent inclination by this laminae and straight solid problems we have worked out. Very easy job. Now you have to decide whether to find beta or not. Yes. Now you take this. Let me take in general. PQ is true length of the item. Here, what is the true length of the item? 60. Let me generalize. Drawing beta or alpha. True length is 60. TL equal to 60. Then let me name this as Q. Okay, PQ is true length. On true inclination, what is that? 30 degree. Phi is 30 degree. Then take this apparent length and draw an arc on the moving locus of Q, horizontal locus of Q. Then you get R, say. Then PR equal to apparent length. Even I can say here O1 of true length, O1 of apparent length. That I can say. Everything same. Now join. Then measure this angle. Definitely you will get 45 degree only as beta. Beta equal to 45 degree. Okay, you can try. In this combination you get beta equal to 45 degree. If 45-30 combination gets you 45, 30-45 gets you 55. But any other value like previous problem I did on pyramid, prism, square prism, I have given 40 and 45, you got some around 67. That all depends. Now, after doing this, you can keep here and then rotate. So, if you get any problem, then directly take the 45 degree line here, and you should mention, should have this figure with the same sheet or different sheet, mention to find beta and then keep it. Better you make accommodation there only. Normally, these distances will be given accordingly. Suitably they give, definitely you can keep that figure, or you can keep at the end. I will tell you how to keep at the end also. Here also you can include that. So let me draw 45 degree. So now you have to decide whether you want base on ground, base towards observer or base away from the observer. By default, I will take base towards observer only. So how to do it? So draw 45 degree line, okay, and then fix. Okay. Okay. Now assume that I am taking 45 degree line, approximate line. Then I am keeping this figure here. So there are many methods of redrawing figure. In computer it is easy, move and rotate. So I have to keep this base here and top face there. Now what I do is I will measure this. I will start from this. Now let me name this as M1M for reference. Now I take first MM1 and this. I will briefly give the method. MM1 you keep, measure this MM1 first and mark here. Then draw lines. Then start working. MO equal to M1O equal to MO. So mark here. Then take these distances. There are 3 distances and then finally C1. Then draw lines here. This is O1, O and all other lines. Then you get the figure distances and the corresponding figures like this. See, you have the pattern. You can easily do that. Okay. Now I can say this distance, one distance if you take, this works for 4 points. If you take this small one, it will work for another 4 points. Like that if you do, you will get the figure. Okay, sorry. Let me do initially. Then join. Same figure you should get. Whatever is there, you must get. So this is how we can complete the figure. Should check whether you have taken the same pattern and also visible line image. Everything should be there. In computer it is easy. You try to move and rotate. That's all. everything will be same, and check twice for the angle. Now at the end you should keep the angle reference beta equal to 45 degree, whatever you get. Now assume that you have done there. You are not interested to keep outside or somewhere, here only you yes, you can do. What you have done, take same from the same figure, true length, that's all. You need not go there, true length, but O1 must be available here. Carefully you do it, then fix the true length and mark. This is 30 degree. Fine. From this O, mark a line O1 through O1, draw an arc. This becomes O1 of true length, this is O1 of apparent length. Now get the figure, join. This is what the requirement. Okay, now do this. Everything must be same. So what I have done, I have redrawn this figure such that axis is inclined at 45 degree to xy. Top view of the axis is inclined at 45 degree to xy, or the given value is 30. I have identified beta and got it. Now how to get the corresponding front view? So again project the same thing. This is A1, B1, C1, D1, E1. This is A, B, C, D, E, top face and base. Now project all these points carefully. C1 is very much on ground, that is on HP, C1 dash, then B and T are next level when compared to C. Yeah. Then this is axis O1 dash. This is E1 dash. Sorry, this is D1 dash. Yeah, this one is B1 dash. Similarly, you identify E and A. E and A. You will get these two are very close. This is E dash, A dash. Join them. Yes. You get the base ready. Similarly, top face. You project these points. Better avoid the axis initially. Lead to confusion again. Manually, if you are doing, it's easy to do it. Then first one is C dash. Yeah. Stop there. Then D dash and B dash. D dash and B dash. Next comes E dash and A dash. Yes. You get same figures. Two laminae which are parallel to each other but inclined at same angle with respect to the HP and VP. So you get the figures which are similar in nature. Okay, same figures. A1, E1, A1, DD1, you get DD1, then CC1 and BV1. Because of the changes in the places, you will get this. Now I will rearrange this, assuming that this B is away, and C is inside. Then what I do is, I keep, okay, now I have drawn with red color only, let me avoid this, thin line only I draw first. Then what you are going to do, here I am staying, so observer position is here, base is nearer to the observer. See, this is light color top face, base is nearer to them, base is visible, and then top face is not visible, boundary line is visible. That way you can do. Otherwise, simplest way is D is not visible because D is the farthest item from the observer. Now I can start working the farthest item concept only. So D is not visible. Connecting to that, the all other lines are not visible. Okay. Now let me get you one more information. That is, appears to be inclined at 45 degree to 30 degree TP. What happens? You need not do that. Directly, case 2 appears to be inclined at 30 degree to VP. That means beta is given, that is 30 degree given. What you do is keep the axis directly on 30 degree and say beta equal to 30 degree and then solve the problem. You will see this in the computer software. Let me take the same problem which I worked out just now. A pentagonal prism of 30 mm base edges and axis 60 mm as a base corner on HP such that its axis is inclined at 45 degree to HP and 30 degree to HP. So here you must carefully observe this 45 degree to HP and 30 degree to UP. So in this case, the axis inclined to both the planes. So definitely you are supposed to find beta. So immediately you will get that idea why this axis inclined to both the planes and the beta should be identified. Okay, that you will see in the later stages. Now I have included one more problem along with this, that is same problem. Instead of directly inclined at 30 degree, appears to be inclined at 30 degree to VP. You will deal with this separately. Okay, I will give the hint for this, what you have to do and also find the answer. Now, let me take first one and do it. Before that, for both, it is common information that the axis inclined to HP, and for that make it perpendicular to HP so that to get to the true shape of the cross section of the prism on HP. So now what you decide, top view is true shape, hence start from top view. You have to start from top view. It's always there. Now for all solid problem in this syllabus, you have inclination only to HP. Now edge or corner condition, whether edge on HP or corner. In this case, the corner on HP. Yes, see, corner on HP. So what you do is, you try to analyze like this. One of the base corner on HP said the perpendicular bisector passing through the corner to be placed on HP is always parallel to VP in the first position. I will show you how this. See, this is the perpendicular bisector. Sorry, this is the perpendicular bisector passing through the corner to be placed on HP is always parallel to VP. So whatever you do here, that is for VP. Or the side opposite to the corner to be placed on HP, that is AE, is always perpendicular to VP. Then only you will get the inclination only to HP if you incline. At the same time, these two sides containing the corner HP in future, it will be equally inclined to HP. See, if you draw a line further, if you measure these two, definitely these two are same. Okay, because this is symmetrical about this line. Definitely these two will become same with respect to the imaginary line. And if you incline that with respect to HP, these two also sides also equally inclined to HP. Sometimes in question they will add that statement also. You need not worry much about that. It is fact. You have to get. Next, you have to give inclination to the HP. See, this is the initial position, and then give the inclination to the HP by moving and then rotating. So you move and rotate. Yes. After you rotate, you just observe here, I have highlighted this, the axis inclined at 45 degree to HP, or instead of giving the statement axis inclined at 45 degree to HP, you may give longer edge containing the corner on HP is inclined at 45 degree to HP, one and the same. Okay, then you will again give axis inclined at some degree to VP, or otherwise you can give the reference here only. The longer edge containing the corner on HP is inclined at 45 degree to HP and inclined at 30 degree to VP, or you will give first to this, then to axis, one and the same. You have to find beta there also. Not necessarily that axis should be given to axis and the inclination to VP should be given to same. You should see the condition of the axis. If this is inclined, this also assumes same inclination. See, I have identified both 45, 45. Okay. Now, what you have done? This is the second figure front view, and correspondingly you have to project it. For that of manual projection and also computer projection, you better to have this and then proceed. Now project it. So you got base corners and then top face corners. Now you just observe, I have not projected the ends of the axis, imaginary line, because to avoid the mistakes, I will show you how you commit the mistakes. Now without that axis projection, I have done this job neatly. It has come, everything is nice. Now Assume that I have projected axis, not necessarily always you commit mistake. There are chances of committing mistake. See, I have projected it in hurry or by absent mind or something. Instead of marking this point, they mark this. And also in both sides they mark that. One side they mark regular correct and other side. Here both they mark like this. You get random figures. You can observe immediately. You can catch immediately something gone wrong. So for that, don't take chance, and also don't give scope to that. Don't project the ends of the axis at the initial stage. That's all. Now, the thing is, you have projected it and got the all light lines. Now, this is the thing. The initially you take the farthest item from the observer is C1 base corner. Okay, see I have written the farthest item from the observer is base corner C1. C1 is not visible and the three edges containing that corner are not visible. See, what are the three edges containing that corner? See, this is C1, C1, B1, C1, D1. These three corners are connecting to this which is not visible. And rest of the things, lines are available and visible. All are dark. Okay. The boundary line as usual it is available. In this method it is easy. All remaining lines are visible or dark lines. I have made it dark. I have taken dark color and then made it. Now that is only for presentation. Finally you have to keep this with all black and white. Okay, it's easy, and also that is the way of presenting and also giving answer. Now I have done all black. Okay, so easiest way is farthest item from you identify properly and keep those things light dotted line. All remaining lines are dark lines. That's all. Now, what next? See here O1 of second figure top view has become apparent length. We have to give again for the same line. I have to give inclination to the HP. I have given one more information. Initially they give inclination to the what? The longer edge passing through the corner HP, and then change it to the axis inclination to VP. They will change it to axis. Then also you have to see the axis whether it is changed or not. Yes, if it is changed, definitely it has changed. Definitely you have to take the inclination with apparent length and then find beta. See, I have given to get third figure top view, redraw the second figure top view such that O1 is on a line inclined at beta degree to xy. Since O1 is apparent length on apparent inclination. So find beta. This is how you analyze and then see whether to find beta or not. Now, I have given the figure here as well as here. You can do both, and there may be some difficulty after you move and then start rotating, or after by projection, during projection to these very close lines are there, then you find problem. What you do is find all these somewhere here, you identify to find beta, then you take directly on beta direct line over and then project. Finally you can add this line. Okay, that also whatever I have explained, but I could not project all the things intact because of the inaccuracy there. We cannot do it. Okay, sometimes we can do very carefully on blackboard. Now here what you do is you move and rotate on the beta degree line. See, I have given beta degree line. Same thing I have rotated. Then project one by one. Okay, see beta equal to so much. Project one by one and get the, see here also very closely it has come. So manually it is not that easy. Okay, that's why it has not come properly on board. Now the B1, C1 are very close. If you make it fit the regular size, you cannot differentiate between those two. See, it looks like same one. Sometimes it becomes one only, single line. Now what I will do is, now let me do this way. I am here. The farthest item from you is whether D or C. Some people may get confused. Actually it is D. In that case what you do is dot two horizontal lines through D and C. Definitely you will get idea. Definitely D is farthest item from you, because if I draw horizontal line, C is below that. The extreme line is okay D only. Now D is D top face corner is D, that is not visible here. Okay, then any number of lines connecting to that are not visible. In this case I have done that job. See, D is not visible. E dash, D dash, D dash, C dash, and one more line, D1 dash, D dash are joining this particular corner which is not visible. Then all these lines are not visible. And rest of the lines, all remaining lines are dark. Dark, all remaining lines. See, I have drawn all remaining lines. These are very close lines. That's why it has not come properly on whiteboard. So now what you do is keep zoom and then project all these points, you will get properly. So this is how you try to get the final answer. I will zoom it. See, the farthest item from you is D. These three lines are visible, all the rest of the lines are visible. So you must carefully do this job. Okay. Now all depends on the angle of inclination and etc. Now top face visible and do it. Now let me analyze this with the key surface method. See, here is the nearest surface to you. Yes, you have made it dark. Then all boundary lines are dark. Then the invisible key surface is top face. The uh, the three sides are already covered by the boundary line and two more are left. Those two are dotted. Now the again the line passing through D again is dotted because of bends or crossing line or visible surface, invisible line. So you can also have this visible surface concept by keeping this I mean, just for demonstration only I am doing this job, not for anything. Just for demonstration I am doing. Oh, sorry. See, this is to say visible surface, invisible lines. For that I am working on it. See, see, I can say this is visible surface. Say one edge is passing through that visible surface and edge backside behind the solid cannot be happen. Both cannot be dark. So what I mean is visible surface, invisible line, invisible surface, visible line. See this one, A1 is visible line. This area is invisible area. Okay, invisible surface, visible line, visible surface, invisible line. So don't get confused much. It is very clear. Visible surface, invisible line, and invisible surface, visible line. So definitely it works for you. Any type you can manage, any method you can do. Finally, I can say this theta, the value of theta is 45, that is inclination to the axis with respect to HP, fine. And he says appears to be inclined at 30 degree to VP, that is case 2, you can say. So in case 2, what happens is beta is given. In that case, the thing is uh, the angle of inclination for the axis is directly 30, then say here beta is given. Beta is given. So you project again. I think in this particular case you get the clarity in the front view. I will do that. Okay. Now let me start working for the front view again, one by one. See that this is thin line 0.13. Base points. The extreme is C1. It is on HP. Yeah. Then A and E is the topmost points in case of base surface. Yes. E and E. Next comes B and T. B and D. See, here also very close points are there. Still, we can expect some differentiation, clarity. Yeah. Next, I have in this case D. Zoom it, zoom it a little so that you can get idea. Yes. Now join A, B, C, D. This is A. This one is B. A1, B1, C1. This is D1. This is E1. Yes. We check whether all are correct. Yes. This is C1, B1. Let me name also better. Confirm this. Cross check. This is E1 dash. This is A1 dash. This one is B1 dash. This one is C1 dash. This one is D1 dash. D1 dash. I have joined all this and keep it ready. Now let me go for one more surface, that is top face. So project it properly. This C single point is on the horizontal line. Okay. Always prefer to have end point. Then B. B and D must be on a single line, similar to the previous B and D. Yeah. On this line only you get D. Next call, last top line is A and E. E is missing there. I will keep it. See, there are lot many. There is 3 points are there. E dash. Missing. Now let me have E projected. Yeah, projected onto this line. A dash, B dash, C dash, D dash, E dash. Name it. A dash, B dash, C dash, D dash, E dash. Join them in order. All these lines A1, B1, CC1. Yeah, this is CC1. So yeah, something wrong. Let me take very close to this. Then we join. Now B, B1. Then A, A1. E1. These three are D dash, E dash, D dash, C dash, and D dash, D1 dash are dotted. Okay, and remaining lines are dark. Okay. Now let me select these three and then do it. Yeah, these three you select. These three you select and make it dotted. 0.5 and dark line. Yes, and all other lines are dark. All other lines means edges, actual edges. That is the edges of the top face or edges of the base, etc. So you keep all the edges dark, then you will get the final figure. This is how you can complete the solid. And there is a problem here. Okay, you can check this. We select. Have sufficient patience and do it, because the thing is, lot of lines are there. Okay, even hexagon is having same thing. I think all these lines should be dark. Let us see. You can check with the other concepts which I have given to you. Okay, that also dark. Okay. Yeah, now I can. All are dark. Yes. See, I think this they have become dark, light lines. Yeah. See, this is how we can do it. Finally, you project the axis. Project the axis end points so that you get the axis reference. So sometimes nearby lines will catch. So what you do is, in case, zoom it, then try to complete. You will get closer. Then you can avoid the mistake. See here, this one you touch this. Now I am getting. This is the axis point. Yes. Next axis point is this. It is showing midpoint. I have to get this line measure. Okay. Otherwise, we cannot do that job. What I do is, I will take this line and measure from this point to measure this point, that is 18.045. Measure 18.045 from this and draw a line. 18.045, and then draw one line. That's all. Then from the end point of this you measure, project. Sometimes it may not be available. Now we will catch this. Again, same problem I am facing. What I do is, I will extend, I will do extra, then draw the, get the intersection and then trim. That's what. Yes. Now you see that this is to be trimmed and then join. You can stay, you can keep it as usual, but try to trim it. Trim this, trim this. Then join axis points. Okay. Definitely 0.25 or 35. Then axis, third line, join from this point to this point. Here, something is there. Yes. Yeah. Here, this is how we can do that. There is small variation because we have taken distances. So try yourself. Then let me. Okay, axis. So this is how we can do the projection of solids, particularly triangle, square and pentagon with edge and corner condition. Same, different shapes can be taken with the same concept. Then we will discuss in the next session hexagon and pyramid problems.